Saxon Advanced Math Lesson 50 is, we're going into a little more with the trig problems. We've already done quite a bit with trig, and we understand our special triangles. Remember our 30, 60, 90 and our 45, 45, 90 triangle. On this lesson, we're asked to come up with a little bit different answer, and that is if I was given that the sine of theta is equal to something, and I put the sine of theta equals to 1/2, I would know that's a special triangle. Why? It's a 1, 2, √3 triangle, and if I knew that, I should be able to look at that and say the sine of 30 is 1/2. And that's true, and that should be it, right? Except that we have to start defining some things. See, there's a lot of things that could give us the sine of something equaling 1/2, more than just 30 degrees. I put up there, well, what if it was in the first quadrant? That is a 1/2, that's a 1/2. There's my 30 degrees, no problem. If I jumped over and I said, well, what about a 30 degree in the second quadrant? All students, that's still positive, and that would also work at 150 degrees over. If I jump down to the third quadrant, it doesn't work because that gives me a -1/2, right? Opposite over hypotenuse. And same with the fourth quadrant. So these two don't work. But and that's great, except what if I were to look at it and say, well, from here to here is 30. What if I continued and went all the way around the circle again and added 360 to that? That would give me 390. Well, 390, if I do the sine of 390, it gives me 1/2. And if I go 360 added to my 150 there, I still get it to work out at 510 degrees. So if I went all the way around again, I would end up with 510, and 510 still solves it. And then I also have, well, what if I went backwards? -330 and -210. So I went backwards, right? Those would still give me 1/2. So which answer am I looking for? Well, the problem is there's no limits on my original problem. It just said, what is theta? Well, theta could be 30, 150, 390, 510, -330, -210. And any multiple of 360s of these would continue to work. So this gives me lots of answers that all are true. It's remember that when you're saying the angle whose sine is equal to 1/2. Well, unfortunately, there's a lot of angles that equal that. As long as I can keep adding 360 or subtracting 360, I have an infinite number of answers. So if I look at 50.1, we're going to start adding in there some limits. And the limits that they're going to say is solve the sine of theta equals 1/√2 given that theta is greater than or equal to 0 and less than or equal to 360. So what that's going to do is that's going to limit me to one time around. No negatives and only once around. If I had put those limits on this one right here, I would have only had these two, right? 30 and 150. They're the only solutions that work. But on 50.1, they're giving us 1/√2. It's still a special triangle. It just happens to be a 45, 45, 90 triangle, if you recognize that, 1, 1, and √2. And if I looked at it and I applied my memory tool, all students take calculus. All the trig functions are positive in the first quadrant. Only the sine is positive in the second. Only the tangent and only the cosine. Well, if that's true and I'm looking for a positive, I know it's going to be in my first and my second quadrant. Of course, it could be multiples of those of 360, but this limits that down, and it can't be any negatives. That limits it the other way. So I'm only going to have two triangles that work for this. When I look at it and say the sine is opposite over hypotenuse. So if I say opposite over hypotenuse and opposite over hypotenuse, both those give me a 1/√2 triangle, and both of them work. I can't be in the third quadrant. The third quadrant, the sine is negative, and that would give me a -1/√2, so I know that one doesn't work. And the same with the fourth quadrant, where only the cosine is positive. So on this one here, when I'm solving it, I say, okay, well, that's easy. It's just 45, right? That would be how many that degrees, there's my special triangle. And 180 minus 45, which is 135. So then my only two answers are 45 degrees and 135 degrees for having a 1/√2 with the limits of 0 to 360. Look at example 50.2, and this is where we start getting into the meat of the lesson here. And we're going to throw this in, and we're going to say, well, solve 2 plus √3 secant of theta equals 0. Don't shut it off. It's okay. You can do this. I'm going to do some basic algebra first. I subtract 2 from both sides. That gives me root 3 secant of theta equals -2. Then I divide both sides by the root of 3. And now I have something that if they would have started with, I would have known what to do with. As long as I remember that, wait a minute, the secant goes with the cosine. 1 over the cosine is equal to the secant. Which means if I did an inversion on both sides, I could say the cosine of theta is -root 3 over 2. And remember why I can do that, because the inverse of the secant, if I flip it, I say 1 over the secant is equal to the cosine. And I can get it to a trig function that I recognize by saying 1 over. Well, 1 over the fraction of -2 over root 3 is -root 3 over 2. It just flips it over, right? So if I'm doing this, now I'm looking and I'm saying, well, the cosine of theta is a negative value. I wrote my little terms down here. All students take calculus, and I look at it and say, well, this is positive for the cosine. That's all, but I want a negative. This is positive for the sine. Whoa, that means the cosine is negative. This is positive for the tangent. Cosine is negative. This is positive for the cosine. Cosine is not negative. So I know it's going to be in my second and my third quadrants. I go ahead and draw my triangles, and I realize it is a -root 3, that's my adjacent over hypotenuse, that's what cosine is, and I say my hypotenuse is 2, so -root 3 over 2. I immediately recognize this as a special triangle, right? 1, 2, root 3 triangle. So I stuck a 1 out there. I don't have to, but I throw the 1 in there just so that I recognize this triangle. When I do so, I realize this is a 30, 60, 90 triangle, and that is a 30-degree angle in there. I do the same thing in the fourth quadrant, realizing that's a 30-degree angle. And my drawing's not very good there. It looks more like a 60 or a 45, but these are just sketches, so that's okay. And I realize it's a 1, 2, root 3 triangle as well. And that gives me my cosine of root 3 over 2. This is going to be a negative because that's the x-axis, and going to the left throws it into the negative quadrant side. And that works out well. That's what this was telling me, that the cosine is negative here and here. So it is first or second and third quadrant. Well, if it's a 30 degrees in the second quadrant, that is 180 back 30, right? And that gives me 150. If I went 180 plus 30, that's going to give me my 210. And those are my two answers, 130 and 210, with the range being here. Now, if this range was double this, I could go around twice, right? If this this was not 360 or was a bigger number, I would look and say, well, how many numbers do I repeat? And I get to 360 or get to the top number, that's when I stop. Or if that's a negative number here, I go back to it and I realize the multiples of these that are going to work. But these didn't. This limited me down to just 0 to 360. And the only places where the cosine was negative was second and third quadrant. So I have second and third quadrant triangles, and I just put in what those degrees were from my special triangle. This problem required you to know a couple of things extra. One, you had to recognize that a secant and a cosine are related. Okay? Remember that tangent and cotangent are related, if that would be the other relation. So I have to be able to do that and realize that flips this over and puts it into one of the trig functions that I have these memorized on. And then I go ahead and just graph it out, place the sides where they lie, right? Adjacent over hypotenuse, that's cosine, and that's what's going to put these triangles in the second and third quadrant. And then I just assign the values that would be from 0 to how many is that, and from 0 to how many is this, and that's 150 and 210.